A lot of people say that making 2D games is a great way to start learning using game engines and game development in general. I don't know about that, but I've been making Armory 3D content for a while now, and on this Armory 3D community channel, which is a new channel, I've been making a ton of videos talking about how to use different features inside of Armory 3D. I haven't really talked about using specific mechanics or making specific game styles or types. I've just been talking about how to use like variable systems, the level of detail system, score, all this type of like raycasting, all these really general points. And I really want to put all these together, well, not all of them, but a majority of them, and make a really simple and comprehensive game. So to do that, I decided to make a simple clicker game. Now, we're actually going to use the draw nodes to actually draw the player. We're going to use the raycasting to do a bunch of stuff. We're going to use variables. It's going to be very simple, very comprehensive, but I'm going to try and cover many different things. Really just to show you guys how you can actually apply these to an actual project instead of just generally saying, hey, this is how you do this. So we can go ahead and set up our camera right now. And the reason we're actually leaving in this cube guy here is because we need something to raycast. We need an object, because although we can use an image as plain and just use that as our player, I do actually want to show you guys how to use the draw nodes. So let's go ahead and add a new node tree. We're going to call this one player because we're going to have it be our player and we're going to apply all the different player logic to it. Now this is going to be a very basic clicker game, but a timer based one, so you have to click as fast as possible. Firstly, let's go ahead and grab the render 2D node, because what we want to do first of all is obviously create our player. What I got is I got a basic image, so we can go ahead and draw our image on screen using the draw node. Now this is a great alternative to UI to do things like this, because making 2D games is annoying, and I love this approach of having 2D, 3D-ish. It gives you the best of both worlds and it's just really fun to do. So let's go ahead and add in, well, all these different dependencies, all these different things that you need to set to actually make this node work. First of all is a file, an image file. So let's go ahead here, press that folder icon. It brings you to wherever you saved your folder. I just saved it in my temporary location drive. Let's go ahead and add a new folder. We're going to call this bundled. Now this is necessary, this is mandatory. You have to call it bundled, capital B, spell it correctly. And this is your assets folder. The reason it needs to be spelled correctly is because this is coded into Armory 3D that it looks for this folder to find things like fonts and images. So let's go ahead and add in our image. Let's go grab this cookie guide that I downloaded off the internet. You can grab whatever your own image, whatever you want. I'll leave a link to this one in the description, I think, if I remember. So let's go ahead and reference this as the player.png. Make sure you have the name and file extension correct. Next down is the color. You can add a sort of tint to it if you like. You can change this at runtime using another video that I made. We're not actually going to do this for this video, but it could be interesting for like as the timer goes down, if you're going into the last couple of seconds, to change it to something more menacing like a red. It could be interesting. For now, let's just stick to something simple. Right now you have these two new boxes. I believe they weren't here when I covered the draw node in the draw nodes video. So essentially what they are is they allow you to center your image to wherever you want to center it, or to the middle, to the top, to the bottom, to the right, to the center. It doesn't really matter what you pick. You can see we have 0, 1, 2, 0, 1, 2. So you just set it to whatever. For example, 2 here is going to be going to the right. 0 you can see is top, so you can leave it at 0, so here it will be on the top right. However, that's not exactly how it works. If you tried that and it doesn't work, it's normal, because it doesn't actually use the screen, it doesn't use the camera as being the canvas. Well, I mean, it does in a way, but technically, if you look here, the X and the Y, these are actually what controls where the player is. This just focuses it around those coordinates. And right now, 0, 0 doesn't mean the center of your canvas, of your camera. It actually means the top right inside corner. That is the origin point, just like you would have in Godot, I believe. So yeah, this is essentially the center, so we can modify that by getting the location of our object, or we could get the Windows resolution and then just divide it by 2 using the math node, and then it'll be the center of your window. But for right now, we actually want to host it to this object over here because we want it to move around, remember? We don't want this to be static. So we need to go ahead and convert the world coordinates to screen coordinates, so we can grab that node. And this just converts your world coordinates so it's 2D, so now you can separate out those coordinates. Separate X, Y, Z. We only want the X and Y, remember, because we're doing a 2D game, so we're not going Z into the depth. So plug in the X and the Y. And obviously we need to remember to add in some width, because right now this would be fine. It would be moving or adding this object to our player's position, but it doesn't have any width, it doesn't have any height, so it doesn't have any pixels to it. So we won't be able to see anything. So let's add something like, I don't know, 250 pixels seems about right. Let's go ahead and add in a white background. Now this is subject to change, so let's go ahead and run this and see what happens. Wow, look at that. As you can see, we're off center. That is normal. That's because of what I talked about earlier, but yeah, the size is pretty much good. We're actually going to scale this cube down actually because the cube's a bit too big. But what we have here is our image is centered to our object. You can see we're centering to the object. We're getting the object's location. We're converting it to screen coordinates, and then we're getting the screen coordinates in the X and Y, and we plug them into the draw image. So the draw image is going to be at this object's position on the screen. So what we actually have is we have a little problem because 0 here means left top. So set it to the top left. What we want to do is set it to the center middle 1 1. And now we can play this again. And there we go, it centered it to the center middle. I don't know if you can see that white cube behind, but it centered it completely perfectly. See, that might be a misunderstanding that you guys might have with this, because it doesn't actually get the camera's center as an origin, so you're not centering it to that to the actual center left or right of the camera itself. You're centering it to the object's location. So that's just something that you should understand. Now we can go ahead and just bundle these up, call it draw player. So once we've got that, we've drawn our player on screen. That's great. That's we could have just pressed Shift A import. But yeah, no. Now you should understand the basics of using the draw nodes, and obviously this is updated every on render 2D. So this happens every single frame after the update node has finished doing its thing. So if you want to modify things like the color or the actual image file itself using like a variable, that is completely up to you. But for us, we're just going to leave it as is, and we're going to go ahead and actually create a mechanic. That mechanic is going to be a click. So a raycast, we're going to detect if we've clicked on our image. So if we clicked on our cube over here, which is obviously essentially acting as our collision boundary, our collision object. So we can go ahead and grab the mouse node. Obviously this will also work on mobile as a touch, if that's also what you want to do. And obviously the object we want to raycast is going to be our cube, but obviously our node tree is already hosted on our cube, so that's the default object anyway, so we could just leave it blank. And we need to get the cursor location. You might get it confused with get mouse location. No, it's get the cursor location in this regard. And it's the X and the Y that we want, so plug those two in. And the camera is obviously our camera. So now we have a bunch of different options. One that we do want is just the true, really. If we have clicked and it is over the cube, we want to send out a message. That's all we want to do. So what we want to do is we want to send out something that repositions the object and increases our score. So for right now, let's just change the object's position. So we can set transform. Yeah, we'll use the transform node. Set objects transform if true. So if we have clicked, set the transform of our object. The transform constitutes everything, the entire 3D position of our object, scale, location, rotation, everything. So we can go ahead and grab the transform node. You can see here. Let's actually zoom out and give ourselves some more space. I'm going to bring up this window, press N, and plug that in. We messed up. We don't actually want that in there. Right, we want to plug this in there. It's a rather large node, so I'm just trying to show you guys. Right, so here we have all the different coordinates of our object. We have the scale, obviously rotation and whatnot. So let's go ahead and just add in a random vector. So we talked about randomness on the channel or also on the random video, randomness video. So you can go ahead and grab the random vector node. So what we want to do now is just add in the screen coordinates. So obviously if we press the end panel we get the coordinates updated live. So let's just go to up here on the Z, see how far you can go. Probably about 2, so obviously when you go down it will obviously be the same value inverted. So let's go ahead and add in 2 and -2. So that is the maximum you can go up and down. Up is obviously +2 and down the farther you can go is about -2 on the Z axis before you're off camera. So now obviously for the X we can just do the same thing, and you just see the X is about -4. Yeah, we'll call it -4.4 or 3 -4.4. Just call this one 4.3 and this one -4.3 for the sake of consistency because we added -1 here. Anyway, this is the positive on the X and Z and this negative on the X and Z. That's as far as we can go on screen coordinates. You can just manually check to see how far you can go by just moving your cube around and seeing the different values update. And there you go. Now we have the maximum distance that we can go, and this only applies if your mouse click is over the object using the raycast tool. So we can see if we click on the side, nothing's happening. If we click on our little cookie guy, boom, he moves out of the way. He's got a brand new path. And obviously we have the cube behind him, so we can actually disable that now. So it won't show up in the render, it'll just be a flat 2D cube. So essentially just like a normal 2D game. And since we obviously set the Y value to a 0, because in this case in Blender, Y is actually depth, that's forwards and backwards. If you set that to something other than 0, it would actually be moving forwards and backwards as it moves along. So that's not what we want it to be 2D. So yeah, we have the movement system set up, everything's pretty good. The one thing we need is actually just a variable, just a score. So let's go ahead and add that. Now this is actually going to be a property tool. Now to do this we're going to use properties. So let's go ahead to our objects data tab over here, go down to our properties section and add in a new property. This is going to be an integer, I guess. Yeah, we want solid numbers. So let's add in an integer and we're going to call it score. A highly creative name. So this score is going to be set to 0 by default. So we can set score. No, not set score. I'm sorry, I got lost. Set property. We're going to grab the set property node, plug into the transform. So as soon as it's moved it around, it's going to update our score. And we're going to update it to +1. So to do that, we need to have knowledge of what our score was previously. So we need to reference the score object property that we just created down here. And we need to give it a value. And its value is going to be whatever its value was before +1. So if it was 5 before, it would be 6 now. So to do that, we need to actually get whatever property it was previously. And we're going to add in a bit of math. So we can reference it as the same score. We're getting the score, adding +1. So we can go ahead and grab a math node. By default it's set to addition, so that's perfect, and we can just increase it to 1. So we're getting the property of score, adding +1 and updating that to be the new score. And so when that cycle repeats, if we're from 0, it's going to add 1 and then set the score to 1. And if we repeat the cycle, it will be then 1 plus 1 being 2, and set that to be the new score, and then 2 to 3, and the cycle repeats. So that's updating our score essentially. But we don't have a way to display our score. So what we want to do is we need to do another draw nodes tree. So what we're going to draw now is we're going to draw a string. And what we want to do is, let's just copy and paste this update node so we can have more flexibility and actually see a bit better. And we can zoom in, and what we want to do is we need to add a new font file, and this font is going to be our variable. It's going to be our property, which is going to be obviously the score. It's the only property we've created. So let's go ahead and grab this score. We're going to reference it, and it's going to be our string, the number that is going to be displayed on the screen. The value, the font is going to be, I don't know, about 75 or even 100. Let's just see what 100 gives us, and we're going to set it to black because we have a white background. Its position is going to be, we're actually going to add it to the player. We're going to do something interesting, pretty much improvise at this minute. So let's go ahead and get the objects. Look, actually no, we can just use this node tree, can't we? You know, I've just come up with a new idea, so bear with me on this. We're just going to add this object in here into this node tree section, and what you can do is you can see we can actually just go ahead and use this location and just do a bit of math and then have this object be above our player. So let's go ahead and just plug in the X into the X over here, and we can go ahead and grab a math node, and what we want to do is we want to add it, oh no, we don't want to do that, we want to add it to our X, and we want to add it a couple value above our X. So I don't know exactly what. Let's test 50. It's probably going to be too high. Let's see. And well, obviously we need a font file, so let's go ahead to our folder and go to our bundled section. You can see we don't have any font. This one right here, that sounds like a good font. Bundled folder, add in this font. We're actually going to change the name. We're going to call this one just font.ttf. I know, my originality is through the roof. I'm insane. I'm on a winning streak. Let's call this, let's reference this font.ttf, and let's decrease this to about 75 now actually. And you can see now what we're doing is we're actually getting the object's location, the cube's location, and adding +1, and you can see this is way not high enough. So let's go ahead and add in increase a value 250 and test it out again. And you can see my mistake. I was increasing it in the wrong direction. So let's go ahead and add -175, something of that nature. So it just goes right above the player, and it's just a more interesting way of displaying the font. I think -190 is going to be the winning number to just give us an interesting position. And there you go, we have a rather interesting position, but it is rather to the side, so adds a bit more math. So let's go ahead and duplicate this math node, and what we're going to do is we're actually going to add it in between here, and we're just going to update our player's position by increasing the amount of position is to the right. So you can see we're on the X here, and we want to go into the negative. If I move the object here, it's moving into the negative. So we're going to add, more like we're actually just going to do the thing properly, and we're going to subtract about, I don't know, let's try 25, and just see what that gives us. So we're just, yeah, it gives us a pretty good position, and you can see when we click, it increases the score, and it looks pretty good. Now that I have that out of the way, we have everything looking rather good. You can see the node tree, it might start to look a little bit daunting, a little bit scary, but in reality it's all very easy to understand. This is obviously now drawing the score above our heads, and also drawing the player's, itself, the player's asset, the player's file, the player's image. And so yeah, this is pretty much the entire game for now. And all we need to do now is just restrict the amount of time the player can play by adding a timer, obviously. So let's go ahead and do that right now. Let's go ahead and add a timer. So what we're going to do for this is we're just going to use the onTimer node. We can actually go below the player here to avoid any confusion. We can add the onTimer node, set it to 1 second, and add it to repeat. So what we want to do is we want to make sure our timer happens all the way up to 0. So we need to test to make sure every second that the timer isn't on 0. So to do that, we need to go and add a timer variable. So this is going to be hosted in our object as well, our player. We can go ahead and add a float for this one, and this just means it can be any number even with decimals. So we can go ahead and call this one timer, set it to 60 or 30, I think 30 might be better, or 45, I think 45 is a good number. Right, 45 seconds is the amount of time you can play, and you've got to click as fast and as many times as possible. So let's go ahead and grab a gate node. And this gate is just going to make sure that our timer isn't equal to something. So we're going to set it to not equal. And what it's not supposed to be equal to is, let's grab a float value. And this is going to be just 0, leave it at 0. So it's going to do increase the timer every single second on repeat, as long as our timer variable isn't equal to 0. Because if it is, we're in deep trouble. It means our timer's over, the game is finished. Put your hands down and leave the room. So we need to go ahead and check the property by getting the property node of the object that we're in and grabbing that value, plugging it in. Obviously you can see we have a color code in the side of Armory 3D. We have green and we have gray, we have red. But however, when you have this shade of green, it means that it can input any sort of data inside of Armory 3D. So you can see we're plugging a gray socket into it because it's a universal thing. It's a dynamic socket. So you can plug in any anything you want, any sort of value, any thing you want, like a boolean, an integer, a string. It doesn't matter what it is, it takes them all. So let's just call this, let's reference it as being the timer property variable that we want to check and make sure it's not equal to 0. So if it isn't, then we can go ahead and decrease the timer. So we're going to set property, set the object property, the property, the variable being timer. We're going to get the timer just like before. We're going to get what it was previously and we're going to decrease it. So we're going to grab the math node and we want to decrease it by using the subtract and decrease it by 1. So every second the timer is going to go down by 1 because that's how timers work, you know. So we obviously need to reference the one that we're grabbing as being the timer, subtract 1 and set it to be the new variable. So everything is good here, but it doesn't actually display it. Currently this is just, you know, changing a property, changing a variable, and obviously if we do reach 0, nothing happens yet. So while we're here, let's just make something happen, and that is to set the scene active, and that essentially means change the scene, and the scene active is going to be this scene. So it's going to reboot the level. We're setting this level active, and the level that's going to be set active is the one that we're already on, so a restart essentially. And let's go ahead and just hide that under that. And so what we want to do now is we need to actually draw this. We need to draw this timer, this variable. So we can grab this node and just lump it together. I would call this countdown. And once we've counted down, it's going to restart a level, obviously, by restarting it. So let's go ahead and draw another number. This one's going to be our timer, and we're actually going to do something interesting. We're going to add a variable to a string. So let's go ahead and use the draw string node. And obviously we're going to do the same thing. We're going to grab the font.ttf that we added to the bundled folder, and we're going to set it to probably about 105, set it to be a darker blue. I think that would be interesting. And its position, let's just leave it as is. In fact, let's just decrease it by about 20 and move it across by about 35. Something just a little out of the corner, because obviously the origin is going to be in the corner of our screen over here. That's where we want the timer. But the main thing obviously is to add in the string, the number, and that is going to be our property. So we're going to get property, which is going to be our timer, and we're just going to display it by using the draw string node. And so yeah, that's all you need to do to display it. The main thing has been done just by decreasing the timer and updating the property, updating the variable. And this gate node is just making sure we haven't hit 0, because if you don't do that, when we hit 0, it's just going to keep going into -1, -2, and that's not ideal for a timer. As you can see, we have 45 and we're counting down really fast. We're just slightly out the corner, and we have our little cute player that's moving around here, and we can click multiple times and we can get the highest score possible. The score is a little bit close to our player currently. That's not the most ideal, but let's just see if we hit 0. There we go. 3, 2, 1, 0. Restart. There we go. Everything is working completely fine. Obviously, it's not the most beautiful game. We just got a very bland background, a very simple player. Our score is, I'm pretty happy with it, especially because I didn't plan for this. I had the general idea what I was going to do. I just thought about having the score slightly above the player, like literally in the moment. So let's go ahead and augment it, set it to -210, just slightly further out, just a little above the player. Now obviously this is a really simple project. You can see it plays further out now, and it's just very fun, and there's no high score system currently. I've talked about making that in a previous video using the read and write storage nodes. But yeah, this is our entire game using just a couple nodes, and all this is going to be available in a GitHub page down below in the description if you want to go check it out. Although with this tutorial, I'm pretty sure it's very easy to recreate. Not a lot going on here, very simple to do. The most important thing and the most difficult thing to understand is really the drawing part. You can use UIs inside of Armory 3D, so you can actually remove the majority, or like half of these nodes aren't necessary. Like this entire section down here is just added on. All you really need for this entire game is just this. But I wanted to talk about the draw nodes because they're very interesting to understand. But they could be replaced using the canvas and just adding a simple text object. And yeah, it's very easy to make this sort of game. So thank you so much for watching. I had really a lot of fun making this video, and I hope you did had a lot of fun watching it. So I'll see you in the future. Until then, stay safe, and I'll see you again someday.